hello everyone. Thank you for tuning in, all 17 of you. So this is going to be a stream kind of solving the challenges, looking through some of the CTF challenges, taking questions, kind of very chill, very relaxed. You know, we're not going to rush through them as quickly as possible, like some teams definitely did during the CTF. We're going to kind of look through them in more detail and have some, you know, kind of look through, if we have time at the end, kind of look through some of how some of them are made, because some of them are actually really cool and I'm really proud of how some of them are done. And if anyone shows any interest whatsoever, I will very happily explain all of the Docker stuff behind it. So yeah, you know, let's go right into it. Let me know, by the way, if my audio and video are right. Yes, let's turn the music down. That is a good point. All right, yes, the login page one. Unfortunately, we actually are going to go in order. I say unfortunately. We're going to go in order, which is a good thing. The last one, I just finished writing up the write-up for the last one about 20 minutes before this stream, so I reminded myself how to solve it, and yeah, we'll talk all about that later. Yeah, no, mine is coming later. I'm really proud of mine. We can't skip it. Mine is absolutely wonderful. The source code of the challenges will be made available. I will make it available towards the end of the stream, along with all the write-ups. So if you hang on, I'll show you where all that is. All right, so this is the scoreboard. First off, oh my gosh, like I expected, it's a mini event for the Hack the Midlands event. Like it's not the whole thing. It's just a very small part of it, right? That said, finishing like most of the challenges within like 3 or 4 hours of them being released is quite impressive. And I was just kind of sitting there watching them go up. And this is the last one. Yeah, I'll go more into exactly how I screwed up those challenges and why there's a bonus challenge at the end. Heads up, I completely screwed that up. So we'll go through. But yes, everyone who took part, thank you so much. It was so much fun. I've had some fantastic feedback, and you know, if you have any more feedback, please chuck it in the chat. Take it out on me if you got stuck on a challenge and were really upset about it. Hopefully, you'll see that the challenges are designed with a way through. You shouldn't need to have brute forced or guessed. I did notice a few people were doing that. But let's get started. So I've created a new account on here. Hack the Midlands has ended. Thank you so much. That is, yeah, okay. We'll see how this works because I hopefully should be able to submit flags. So on the lovely first challenge, we have 54 souls for this. Oh, someone obviously had a very long nickname. Oh, where is it? It's this one. Yep. Nope, it's gone now. Cool. So Discord. Welcome back to Hack the Midlands. This year's CTF is full of mystery, intrigue and surprises. It's just meant to be a bit of fun. But I've heard whispers that there's a bot on the Discord server who's giving out flags. Seems dodgy. Alright, so let's pull up Discord and hope that no one DMs me. Please don't if you have me, because that will just distract me. So in the Discord server, there are many channels and lots of people. But if we can look down here on the roles area, you can see there's organisers, the Velociraptor, and then our bots. So we see our bots here, and there is Flagbot with a very helpful status of playing Capture the Flag in DMs. So most of you really easily worked out that the correct thing to do in this case is just to message it. So saying something like hello, and it will say hello back in this kind of form. And so it says fake shell, command not found, hello. Now, this is an interesting thing because lots of these challenges will require that you either have some knowledge, but the earlier ones are designed so that with a bit of Googling and a bit of looking around, all of them should be completely doable and possible, even if you don't have loads of existing knowledge. So, fake shell, we can Google fake shell. Let's just have a look at that. And nothing really comes up. It's kind of like, great. So let's try something else. The command not found part, not the hello part, but let's just look for command not found. And if we Google that, aha! The very first answer is a thing on Linux. Command not found, errors and solutions. So people in this post, if you read through it, are talking about how they can run commands on Linux, what those do, and then this is a common issue. So if I pull up a terminal on my Linux machine, if I run a command, I can do ls or something like that, and list files and things like that, print working directory to show where I am. But if I just type something that is deliberately wrong, command not found, it's that same format, fake, the name of the shell, which in this case is fake shell, command not found, and then the name of the command. So if you're used to Linux or you're used to using that kind of shell, that should immediately stand out to you. If not, it's just a Google away. And this will be a kind of theme that I'll keep coming back to over and over again, is that the only way that I manage to solve CTF challenges that are made for me and stuff like that, the only way that I manage to solve them is just by Googling. So I say Google, I'm using DuckDuckGo just for, you know, got to rep DuckDuckGo as well as ZSH. So now that we know it's a shell, there's some common shell commands that we might want to try, and usually the very first thing that we might want to do is might want to list files. We can do ls, and we can see that we know we're on the right track now because it's given us this list. It's given us bin and data. Bin in Linux is usually a directory containing programs, so we can, you know, list those files as well. And we get a list of programs that are installed in this shell. So we've got cat, which will print out files. We've got echo, which will echo things back to us, like hello world. We've got groups, which we can run. Just says we're in the fake group. Cool. PS, we can see what programs are running. There's only the fake shell programming running. Print working directory, we're in the root directory. And like some other stuff like who am I? So we are the user fake in the group, fake running the program fake shell. So the fact that it's all fake kind of implies this is not a real shell. And slight behind the scenes, it's 100% not a real shell. I was not about to give everyone access to a Linux box where they could run arbitrary commands for a CTF. That was not going to happen because I've done challenges that are like that before, and I hate the idea of trying to make those secure. And for a Capture the Flag competition, which is focused on security, it feels like it might be nice to have some decent security in the challenges. That's why you can't CD. The reason you can't CD is I sat down to write this challenge, and CD requires that you track context for each user. If you just run commands and reply to them, you don't need to track users. You reply to the same thing. If it's the same message, you reply with the same thing. It's all completely deterministic. If you have CDs, now you need to keep track of where every user is located, and that was just work, and so we didn't have CD, because it's a fake shell. So, back to listing files. We've looked at bin, let's look in data. There's a flag. Cool, so we could try and list the flag. And it says flag, so that means it's a file. When we do ls and it just gives us the same thing back, it's probably a file. So we can do cat data flag to get the contents. We get this, and lots of people were messaging me saying, well, what is this the flag? Lots of people submitted this flag. This is not the flag. It says, oh no, the flag's not here. Someone must have been and hidden it somewhere else. So, slight hint in that, someone must have hidden it. Hidden files on Linux are a thing. And it's a file that's prefixed with a dot. So, you know, if it starts with a dot, then the file isn't shown by ls. But we might not know that, and so we might keep looking around. And so we might actually try and cat some of the programs to work out how they work. So we can cat bin cat. And we're given like this little Python script that shows how it works. So it will go through the files, look up the right file. If the file doesn't exist, we'll tell the user. We can't print directories, and you know, we can't print files that don't have contents either. Okay, what other things are in bin again? Let's see. We can cat ls. And so we can see here that, you know, we've got this file name, and we've known that we can list the file name, but there's also this extra argument called flags. And so in this flags argument, we say if flags starts with this dash, which is usually how we indicate flags on Linux, if A is in there, we'll show the hidden files. So we're going, this will show the hidden files. We know that the file has been hidden, so let's try and do that. So we can do ls-a. And we get this. Now, this is because the ls command is implemented extremely lazily. If we do ls like this, -a, it will do it. On a normal Linux system, if you just did this, it would work that way round. But because of the way that the ls command is written, the first argument has to be a file name and the second one has to be the flags. So as long as we keep that in mind, so there's nothing directly in here. Bin data. But if we look into the bin one, we see that there's no hidden programs. If we look into the data folder, there's a .hidden file. So let's cap that. Ta-da! And we have the flag. It gives us that. So go into this portal and submit it. Please let me submit it and unlock the next challenge. Good. Now, please wait while I have a small moment and make sure that all the dependencies for the challenges are removed so that I can actually see all of the challenges. There we go. Here we go. Requirements. Remove the requirement. Good. So how did people find that challenge? How long did it take people? I'm really curious. Secret feedback challenge, yes. That I was planning on releasing, but have temporarily forgot. So I'll release it at some point during this, maybe. We'll see. I can't remember if I got actually the form in any reasonable way before I did that. Okay, so now, if I go back to Discord, get back to here. Whoa, no dependencies anymore. Wow. That was very secret, right? Okay, so I can't actually solve them because the challenges ended, so unfortunately, yeah, you can't get points for any of these anymore, which is kind of sad, but, you know, you can see if you're right, and you can solve them along. So that was Discord, and when you unlocked Discord, you got to login, right? Was that the next one? Why can't I even? Please hold was the next one. There we go. Good. I've totally not forgotten my own order of challenges. Like, people would say, I'm on challenge 2, because my numbering scheme started from 0. And so people are like, I'm on challenge 2. I'm like, what's the name of the challenge? Because I completely do not remember. So please hold. It looks like the bots was hiding bigger secrets. After digging around a bit more, I've found this really interesting contact form, but it seems to have some sort of powerful protections to stop me from talking to anyone. So let's open this up. Ah, what a lovely website. My web design skills are on point, right? So your flag is very important to us. To join the queue, please click and hold to move up the queue. And it gives us a little number of seconds. So let's click and hold. And you can see that it's counting down. Very slowly. So obviously, this is not ideal. This is a lot of seconds, deliberately chosen because it's not something that someone's feasibly going to be able to do. But so we know that presumably when we hit 0 seconds left, it will give us the flag. So one thing that we can do is just kind of a standard practice thing that I kind of encourage people to do. Check the network tab. Firefox's network tab is infinitely better than Chrome's. Chrome has the better like JavaScript debugger. Firefox has the better network debugger. Firefox is the better CSS one. Like, it's just, yeah, there's lots of... I prefer Firefox for lots of hacking things because it's got tools for the things that I care about more. But like, as we do this and it ticks down, we can see that there's no traffic appearing, right? There's no traffic appearing here. This means that all of these checks for when we're doing it are being done client side. So that's great. Because they're all being done client side, it means that we can avoid it client side. We don't have to think about a server side attack. We can just do it all entirely client side. So it's worth checking out the code. So we can inspect the source. Control U opens the source code. And we can see it's a very simple HTML document. We've got the body here with some content. We've got this style sheet, main.css. We can look at that, but like CSS usually is not particularly fascinating to read. Bede might disagree with me. I think he's one of the most talented CSS people I've ever met and looks scary watching him. But main.js is probably where the stuff is. So you can see here that this is horrible to read. it has been minified JavaScript. And the reason that's been done is because lots of websites use huge quantities of JavaScript nowadays. What we do is we reduce the size of it by kind of squishing it in and removing variable names and stuff like that, putting it all into one line so that it will transfer faster over the internet. Sometimes minification will completely screw up the entire thing and be completely unreadable. But this is actually not too bad. They've kept the function names and stuff like that. So what I'm going to do is I'm just going to copy this whole thing and go find a JavaScript beautifier. There we go. DuckDuckGo has one built in. Have you used DuckDuckGo for all these wonderful tools? So we can just chuck this in here, beautify code, cool. We have now the JavaScript code. And what I'm going to do is I've actually got a code editor open so that I can get some, so that it looks slightly less painful to read. That is so that we get some syntax highlighting and stuff. There we go. All right, so here we have the code, and we can walk through it line by line, but that would be boring, and it would be much more interesting to just go, when the counter is 0, get the flag. Okay, that's probably the bit we're interested in. So what we do is we fetch the flag. Fetch is a way of doing an HTTP request from inside the browser. It's the new way of doing it. The old way is terrible XML HTTP request and is so impossible to use. Fetch is actually okay. So we get the flag, we take the current value of the counter to convert it to a string and concatenate it with flag, and then get the initial value of the counter, put it to string, and then concatenate that. And then in here, what we do is, once we get the response, we change the flag element in a text, set that to be the flag response that we get back. And you can see in the HTML, in this challenge, that's completely not the right bit. Here we go. In this bit, you can see that this flag L here, this bit flag, is going to point to this span, which is currently empty. But we can put stuff in it once that is all done. So I've got this bit, please hold, and so we go through to here. So what we can do is we could think of kind of a couple possible approaches. What we could do is we could modify this code before it gets to the browser, so that the browser kind of gets tricked into seeing what the counter is before. So we don't set counter to initial counter, we'd set counter to something like 0. We could do that, but that involves lots of proxying and intercepting requests, and is kind of just completely over the top for this. But it's kind of cool to do. If you want to do that, go ahead. If you've already got that kind of setup working, it's really easy to do it like that. Otherwise, we can just try and reverse engineer and construct this manually. So I'll open up a terminal. And what we can do is we want to construct the URL, which is /flag, and we want to construct this exactly as we need it. So we can use a curl command. So what we need to do is, I've even already printed it out there. It's already got autocomplete, which is terrible. So it's just the URL of that challenge, which is on port 4000, /flag / because when we emit the domain part and the port that we're going to, it defaults to where the page was originally served from. So that's why we've got to put this bit in here. Get flag, and then we get the initial, the current value of the counter, which we know because we've just compared it to 0, so it must be 0. And the initial value is set right at the top, and we never change it, so it must be that. And so we can just do that curl, and it will give us the flag. Then this would be displayed in the web page. But, you know, we don't want it displaying in the web page. It's much easier to kind of just work out what that would be and put it in there. I'm curious, what kind of methods do people use to solve this one? Did people just kind of like, did you just like do this kind of way and work out what should be requested? Or did you change the web page? Or did you do some JavaScript debugging to change the value? Awesome. Yeah, I think this was probably the easiest way to do it. It's completely possible to do other ways, but I don't know. It just seems a bit over the top. Fetch.then console.log. Yes. That's how it works, right? That's exactly how it works. Yeah, there's some really interesting The fetch API I really like, but without using async await in JavaScript, you end up with lots of these promises all over the place. So you end up with, like, you get that, then you get a response, then you convert the response to text, which is another promise. JSON is just miserable as well. So with async await, you could do it, but this is, again, one of the things that if I used async await, it's actually not supported properly in all browsers and all versions. And so I'm like, I'd rather not. I mean, I don't know who's going to be solving this CTF using Internet Explorer 8, but, like, you know, at the same time, it's nice to have stuff not too painful to use. So that's that challenge. We can take the flag and just kind of compare it to the right response, just to ensure that we've got the right one. Close all of that. And we get please hold. Good. Good. Let's remember to put the closing quotes in. Okay. Next, I think it's tux, right? Someone please confirm, because I'm learning out here. Oh yes, it's tux. Great. Just checking my actual solutions. Here we go. So tux. Here you go. Down the rabbit hole. I think this is bigger than we thought. Following on from your findings, I came across this message with a file attached. Gaming is awesome. I love games so much I've started to make a few levels for one of my favourites. It's not really done, but I still think it's fun. Can you take a look? So we download this file. Now, welcome to the fact that file extensions are not accurate. File extensions are a lie, okay? If you live in Windows land, you might have been taught that the file extension configures what thing will open. If you're on Linux land, this is also done. A file extension has absolutely nothing to do with the contents of a file. Sometimes operating systems will use it as a small indication. They'll use it as a small indication as to what program you should use to open it. Like what's obviously happening in this case. You shouldn't always trust it, because you can simply invent your own file extension and use that, or you could just have a file that's of a deceiving type and fool programs. So I didn't realise this when making the challenge, that people would automatically go, let's just use her 3D model. So we'll just save the file and not open it with Ultimaker Cura, because that just won't work for context. And let's just grab that file and put it in here, so we've got some nice working space. Okay, so there's the level1.stl. So the first thing that you should do with something like this is run the file command. I'm a big fan of the file command. I think it's completely underrated for when people do CTFs. Always, 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 if you get a file that you're not entirely sure what it is, run it. It will pick up on all sorts of formats. It says it's an ASCII text file. Okay. One thing that I noticed is people were going really deep into the STL rabbit hole. If you pull up the Wikipedia page on the STL file format, I did not know this. There are two versions. There's a ASCII version and a binary version. It's an ASCII file. The ASCII STL file begins with this line. This file does not begin with that line, therefore it cannot be a 3D file. Yeah, lots and lots of people got tricked up on that. People said, I'm trying to open it, but it's saying the file's corrupt. Yeah, that is completely correct. So the file is actually slightly better than that. It says super tux level. So given that the challenge is called tux, let's look up super tux. Aha! It's an open source classic 2D run and jump side scroller game, kind of like Mario, like Super Mario. It's super tux. So there's a couple methods I kind of want to show maybe to solve this one. I'll do the one that I kind of envisioned at the beginning first. But I'll show some other methods later on, because I think there's a really cool method you can use with extracting data from the file and then doing some fun graphing. So we can download it. I've already got it downloaded, installed through the package manager. And you can see it's a lovely little game. Give me a moment, I just need to... I've realised from my last attempt of solving this, I really, really should delete my progress so I can show it from a clean slate. Yeah, I'm very prepared, you can tell. Okay, let's just open SuperTugs. Great, so there's a level editor here, so we might be able to load levels. So we can go to level editor, and there's lots of things. Note that there is no button to load an arbitrary level. Isn't that nice? So I made this level, uploaded it, tried to solve it, and realised there's actually no way to do that. There's also a startling lack of information online about exactly how to do it. Yeah, there's no startling lack of information about where level files are stored. So I came up with a kind of cool method. And since lots of people are saying that they use regex and matplotlib, I will demonstrate that later. But I think it'd be cool to see this since no one in the chat seems to have done it that way. So what we can do is we can create a world, and what I'll call it something like find me, like a file name that I'll know I'll be able to find later. And I'll create a level in it, and we'll leave it completely blank. And I'll just save the level and exit level editor and quit the game. Right, wasn't that fun? So what we can now do is look for this file. I have a lot of files on my file system, so I'm not about to go looking for them all. But when files are saved like this, there's usually about 3 places they're saved on Linux. They're usually saved in somewhere like .config, and so we could look in home/.config. There's the SuperTux cart, which is also a game I have installed, but no SuperTux. I could look in .local/share and search for like SuperTux, and I can see that there's one called SuperTux 2, which, yeah, I don't know why it's SuperTux 2, 0.6.2. Anyway, this is the right place, and we can look in here, and there's a file called levels, and a place called find me. If we look in there, there's a file called level1.stl. So what we'll do is I will copy the local level1.stl to that directory, overwriting what was already there. So now when I open up SuperTux 2 again, if I go to the level editor, go to find me, and load up level 1, this is the level that has been imported. Which is nice, right? Now lots of people are saying the level editor for this is absolutely not stunning. To make this basic level, I think I spent about 45 minutes trying to do it. I was originally going to have like a really nice, huge level with lots of stuff in it. No, this is about as much as I could do before I wanted to like actually murder this program. It's open source, it's great, I love it. The level editor could use some work. So if you're just stuck here, you might not know what to do. So if we head back to our STL file, there's some stuff we can look through this. This actually looks like some sort of S expression, stuff like a Lisp variant. I think that's really cool. Very few, lots of levels are like binary only formats or JSON or something like that. To have it kind of be Lisp or S expressions is really neat, and definitely something that I will keep in mind for interesting encodings. So there's this part about sector here. There's the name of it, some tile map data. You can just go through. And there's this thing called sector flag, and then lots of bricks. There's a thing called sector here. You might not realise it, but you can click on it. And if you click on it, you can choose sector and go to the flags sector. And in here, you can see that the flag is all spelled out. So all you need to do is transcribe this. It's very simple. It's much simpler than some of the other ones, mostly because I did not want to spend the excessive amount of time it took to spell these out manually. So that's the flag, and we can go and submit that. That's the portal. Epic Penguin. Submit, and it's correct. I'll show off kind of. I'll just ask the chat. Should I continue on with the chat solves so far and come back to this, solving it like the regex and matplotlib method, or should I do that now while we're kind of on it? Up to you guys. So please let me know, and I'll work out what one. I don't know how much latency there is. Alright, it seems to be a majority that I'm going to do that now. Alright, so I wrote a cool script for this, so let's just kind of have it open in the background so that I can refer to it. Alright, so as we're going through this file, you might go, well, it's absolutely stupid that we might just do the absolutely stupid thing and download the program and try and load it. Which I feel a few people did try. But there's also like all these bricks. and they're all laid out, and they all look kind of, there's a lot of them. So, I mean, we can just count the number of them, because it's kind of cool. Count them. There's 240 instances of this. So lots of people are saying regex. No regex. Vim. I don't get the chance to show off Vim that much, so you know we're going to record a macro. Go to the beginning of the line. Delete that, and then we're going to organise it into 2 columns. Editing this bit by bit, and then coming to the next line. And then what we can do is we can replay the macro and do this for each section. I've done 4 of them, and I recorded that there were 240 of them. So I can repeat this macro 236 times. So 2, 3, 6, and Q. And it will now go and format all of these for me. Dun, dun, dun. Yep, that is all of these. So what I can do now is I just want to... I kind of want to just delete everything else. But there's too many lines here. Oh, gosh. Whose stupid idea was it to use Vim? Oh, gosh. Okay, come on. Why is this file so many lines? Okay, there we go. And then let's just delete the bit around it. Okay, and then we'll just save this as points.txt. And now we've got all the points in here. I do have Vim emulation in VS Code. It's not fast. That macro is quite complicated to repeat it 250 times or so, so it's much faster to do it just within Vim. Vim handles those things much better. There is what is in this chat? There isn't much skill required for the early challenges. You could just use Vim. I mean, yeah. I would treat Vim as like, I would say that Vim is a pretty essential skill. Like, if you can learn Vim, you know, Vim is good. Yeah, I don't get to flex my Vim skills that much, so that's kind of why we did that now. Okay, so now that I'm done doing the Vim flex, we've got these sets of coordinates. Some people said they use matplotlib. I think that's completely valid, but that actually requires writing code, and we don't like writing code. So GNUplot is a tool that we can use. So GNUplot is, the options for GNUplot are, it is surprisingly, you know, not easy to use and find documentation for, but it's very, very powerful. Very, very powerful. So what we can do is, we can do plot and just put the file, which is points.txt, and that's pretty much it. And it will plot for us this. You will notice this is horrifically difficult to read, and so there's some more options you can give to it that I found using Google, and I have absolutely no idea how they work, so don't ask. I can say like 0.7, and that should give a slightly bigger size of dots, and that gives filled in dots, and I can give then, I can say the size. Let me just move my Discord window over here. I don't get distracted. Yep, and then we can see here that I can just resize the window to get the flag, which is completely upside down, of course. So I spent about half an hour trying to work out how to flip it because I didn't want to read it upside down and I wanted to have a better demo. So there's a way to do that as well. Of course there is. Not in the documentation anywhere, but you can flip the axis. And then I can plot that again. Ta-da! So yeah, GNUplot is really cool. I will be honest, I have no idea how any of these commands work. I've kind of just been Googling them through. But it's really nice because you can just take this set of points, extracting them using grep or regex or something like that, and then just plot them using a very simple command line tool that's installed pretty much everywhere, which is kind of the reason I was curious to use GNUplot. Some people I also saw used like Desmos, or what was the one that someone used? Yeah, I still think the regex and matplotlib is pretty cool. But yeah, so that is Tux. And so I've now showed the two methods that I thought of. If you have any more methods, let me know. Still more user-friendly than SuperTux. Yeah, that's that is a mood right there. I will tell you though, I didn't you didn't have to make the challenge, which I think took longer than most people trying to solve it. So now we are moving on to login, and I think this is the place where some people started to get stuck. Yeah, if you look at the drop-off, we have 30 solves to like 18, 10 people didn't. Can you make proc-gen super tux levels? Yes, don't. So with your help, I've managed to get in contact with someone, but I just get redirected to this login portal. Okay, so let's head off to our lovely login portal. You know, classy, right? Totally not made and mocked up in like 5 minutes with a CSS framework. Because that would be too easy. Also, I love that LastPass is like, yeah, please fill in your actual credentials here. No, that's not really what I want to do. So we can just put in some like test and password and log in. We get invalid username password details because, you know, they're not correct. So again, this is a really cool thing. We can open up the network traffic and make a request. Hello world. You can see, it's made a post request and then invalid username password. Also, small screw up on my part. When you get invalid username password details, you're meant to return a 403, which is not authorized. Yeah, I just didn't do that. You know, it's not like it's a big deal for the CTF, but in a real world scenario, you would 100% want to give 403, because otherwise you would screw up a lot of things that expect 200 to be, yeah, everything is good. So you can see that we make a post request, so it's not all being done client-side. We probably won't be able to just do a client-side attack here. So, you know, there's also this all.js, but this is from fontawesome.com. FontAwesome provides like these nice little icons and stuff like that. So let's not attack that. There's some Bulma, min.css, and favicon. So it looks like a pretty standard attack. We can look in the post stuff. Sorry, I feel like I've got a really clogged nose and I'm sounding really terrible. Apologies. So we can look at the actual request that we send off. That's not what I want. I want the request. So we give it the username and the password just sent off directly. Good. I'm glad I sound fine. Hopefully my keyboard's also not too loud. Oh no. Someone works at a bank and wants to use the SuperTux format. Yeah, I mean, that's valid. You know, I'm sure it's great to access with SQL queries. Banking data in S-expression format. Okay, back to login. So we've got username, hello, password, world. Okay. So there's nothing like, sometimes when you're looking at a CTF challenge, you'll notice that there will be a form parameter that's just set to something like, am I logged in? Or like, can I do it? Or there might be a cookie set like that. There's no cookies this time. Last year had a cookie-based challenge. There's nothing like that this time. Which is kind of like, well, okay. So now that we've kind of exhausted all the routes of being able to do it, we could do some brute forcing. This is what I noticed some people trying to do. They just tried to list they tried to like hit all of the endpoints on the website. This is doable, but like I always prefer exhaust all of your options before going for brute force, because brute force is not fun. It just takes time, and also if you're in a real attack scenario, people are going to notice if you're brute forcing them. It's just going to happen. It's very easy to notice, so try and exhaust all of the available simple things in front of you before going into the weird, wacky and crazy world. So we can see the code here, and immediately right at the top there's this little script tag, console.log, see the source code here, /code.zip. And also, because that, if you'd also opened up the inspector tools and gone to the console, you'd have seen that that's here. So that indicates we should go to code.zip. And we get a zip archive, of which it wants to download. So I'm just going to save that file and come back to my trusty terminal. And I'm going to make a separate directory for this because, yeah, otherwise it might get slightly large. So I'm just going to move that from the downloads. You can work entirely from inside your downloads directory, but otherwise your downloads directory can become quite large. So again, because it's me, and it's always worth looking and checking that the file is what it says it is indeed a zip archive, or at least its file thinks it's a zip archive. There are ways of tricking file, but you have to be in quite a mean CTF before they decide to start doing that. Okay, so we can unzip it, or use a graphical tool, but command line tools are better. We've extracted all of this lovely information. Now, this is where using a command line tool is better, especially with verbose options in CTFs. If you'd opened this with a graphical thing, you would not have seen these. You would have seen this. And if you do ls, it looks, the .git folder is hidden. So you can't just list it with ls. You have to do ls-a, kind of similar to the very first challenge. There's this git directory. So that indicates that there's probably something to do with git. Yeah, so what we can do is, before we go looking for git stuff, let's just look at the README quickly. README says, super simple and very, very secure login portal you can use to keep your flags secret. So it says, make a flag file, make a password file, then run the server. But none of these files are here. So obviously they've been deleted properly. And if we can, it's also worth looking at the app.py. Actually, let's get a nicer view. Gonna promo bat, like syntax highlighted bat, cat even. Also a fantastic tool available in your Linux repositories near you. So you can see here, it just at the very beginning, it's a Flask web app. It opens password.txt, reads it from the file, opens flag.txt, reads it from the file. It serves the home.html page, but on home.html, so it redirects to home.html on a post request, or a get request even. That's funny. You can do a form request using a get, but because it won't. So you can do a get request there. That's really funny. What I'm saying, so sorry. I just realised this. This applies for get and post. The form can be available in get and post, but this here only checks the these post bits. So if you submit it via get, you have to. Yeah, I know. Sorry, side thing. I have no idea what happens. It's probably not a way you can get around that. But like, yeah. So we can see that the username is hard coded. It's admin. Says my cam is blocking. Please fix. Do you mean like there's some audio delay? Hello, is there audio delay? All right. My camera is over the code. That's what you mean. Thank you. All right. Yeah, my bad. Yeah, I am very new to this entire streaming thing. I spent the first, like, this is why I came in quite early, because I'm like, oh, we're going to screw it up. Sorry. Okay, so here we go. So the password, admin username is hard-coded, and the password is not. So it's loaded from the file. But there's no file, so we don't know the password. Because there's a git directory, let's look in that. So we can do git log, and I think it's a short line. No, line. One line. Yeah. Otherwise, we'll just get loads of stuff. Only flags. That is it's possibly one of my... that's a good joke. I like that. Saving it for later. So we can see these commits. The oldest is at the bottom. So initial commit, the bottom, then a whoops commit, and then this. Git repositories are fantastic to navigate. So there's a couple techniques we could use. If we can go to checkout, ebcd, and autocomplete, ls, and we can see that there's actually a file called password.txt. We can get that and get the password, which is zero cool. Extra bonus points if you recognize the reference. Or if we go back to master, and the file's not there anymore, what we could do is we could also, the git show command is something lots of people might not be aware of. So we can just do git show, and this will show us an exact diff of what's there. So it said it's removed that password file, so we can see that this whoops commit has removed those credentials. TIG all the way. Yes, I've had people rave at me about TIG a number of times. TIG is good. But I've never really gotten it, like, for all the complicated... It's kind of been in the middle, right? It's, for simple, like, manual stuff, I want to use the command line. for really complicated, like really rich diffs and resolving really complicated merge conflicts, I want to use VS Code or something like that. So I don't get where TIG fits in for me, but you know, it is really cool. I don't have it installed though. So you can see the password is 0, cool. So if we copy that, go back to the site and we give it admin 0, cool, we get the flag. And then the flag can be submitted. I don't have to submit the flags. I know they're correct, but it's also really satisfying to submit flags, even if, you know, they don't give points. Got to get that green correct tech mark. So, yeah, maybe they committed the password it's so common. It happens a lot. It happens. So good Git practice involves being really, really careful about committing secrets. There are really good ways you can avoid doing that. The best way is, of course, don't have secrets in files. Keep secrets in your environment variables. So instead of having a file called password.txt, set an environment variable like password equals, like that. Do something like that, and then from within the application, you can read that. You can read that environment variable. And then the reason this is also a really flexible thing from the point of view of when you come to deploy it, because it means locally you can use like a .env file, and your .env file you can just source that when you come in, and it can work really nicely. And you should write a script to populate your environment variables. But in a CI scenario, like when you're using GitLab CI or GitHub Actions or whatever else is popular these days, when you're using something like that, there's a way to just put the environment variables in, and you don't need to fiddle around with the files being in the right place. When they're environment variables, it's also much harder to commit them because you might just put a single .env in your git ignore. Good git ignores go a long way, making sure you don't commit stuff. And if you accidentally do commit stuff, you can't just put another commit on top to rewind it. You have to, if you put another commit on top of that, it will still be there in the history because Git tracks all of that. So you actually need to amend the commit, or if it was far back, you need to do an interactive rebase. Yeah, it can be a bit painful to do, but learning how to do interactive rebases is the most wonderful thing ever. It's like, I feel like there's a whole possible workshop there, like, you know, all the things on Git that you aren't taught, the things that everyone skips by, the things that everyone forgets. I think interactive rebasing, people aren't taught it, but it's one of the most powerful techniques that Git has. Use Vault, yes. I've personally never used it or deployed it, but I'm looking into it I've got a little collection of CTF infrastructure, which I keep running, which is what all of this is running on. I'd love to use Vault at some point, but there's not actually that many environment variables that are required during. The only thing that I actually have is the Discord token is in the, that's required. Anyway, sorry, that was a tangent. That's login. There's just a Git thing. Oh, Git secrets, that's also a thing. There's a tool called Git secret where you actually keep all your secrets committed to your repository, but they're all encrypted, so no one can read them. Obviously, this is a problem if you leak the key by accident, but it's kind of cool. You can keep it all done. There's like a whole thing with sealed secrets with Kubernetes stuff as well, where you can seal your Kubernetes secrets and keep all of your Kubernetes configs in a Git repository. But yeah, in general, committing secrets to a repository is a really bad idea, always, even if it's a private repository, because one day it might not be private. Okay. Oh, he brings in Kubernetes. Yep. Of course I do. Okay. The next challenge is, I wish they showed in order. Flag Vault. Good. Yes. People got stuck here as well. 12 solves. So pretty much everyone who did the last one was able to get this one. This one is not as hard as some of the ones before. I think it's relatively easy. But the reason I wrote it and the reason it's here is because it is based on a real world vulnerability, and it is hilarious. I think it's one of the coolest vulnerabilities I've ever run into because it's so obvious in hindsight, and it's a user experience vulnerability. It's not like some super complicated series of commands I said relatively easy. Is this another joke now? You'll see what I mean once I do it. I'm sorry. I apologize in advance. All right, secret key. Let's go back to the network tab, see if we're doing what's happening. Note that no requests are being made. This is all done on the client side. Awesome. There's a demo with really great music. Yup. And it shows someone typing in a password. Lovely. Yeah, the production quality on this, I obviously spent many hours, right? It shows. Did you guys hear the music or no? Just there. I've also realised that Spotify's quite quiet, and I'm missing the chill vibes on my stream. Slightly louder. There we go. Alright, so that's kind of cool, right? Good. Otherwise it would have overridden terribly with my voice talking. So it's all done client side, so let's take a quick look at the source again, or just the HTML. And we see that this time the HTML has also been minified, which is great. Now, this is not so wonderful. There's a few hints in here. If you look at this, it says it's got this little hash in the file name. This is probably indicative that it's been bundled. This isn't some sort of... This isn't just like showing all of the stuff. This is being bundled. You're only seeing the white screen. How are you now? Isn't that nice? How about now? Can you see this horrible bit of code? Yeah, that's the point. I'm only showing the HTML. Yeah. So we've got this main bit. So it's been bundled. Notice this little icon. This is the React app icon. So it's probably like something create React app or something like that. I'll still keep it down because so it's in the center. So we can see these chunks of JS and all of that. It's very bundled. So bundled stuff can be fun to read sometimes. But we can pull up the debugger and see some of the source code for this. Again, so this is the source code for. So there's some JS here. Node modules we can ignore entirely. We could look through it manually, but that just doesn't sound like fun. So index.js has pretty much just this. So it creates an app and then has that hosted. So we've got app and it's got some code. So what I'll do is I'll just copy this back to my nice code editor and we'll call it vault.jsx. So, JavaScript, it's JSX because it's got this HTML kind of embedded in. It's very Reacty. Thank God this was source mapped. I did not realise it was source mapped until I came to do it for the write-up. I am so glad it was, because otherwise the challenge would have been way harder than it should have been. So we can look through and try and work out what's happening. There's this lovely little hash here. Anything called a hash, it's usually worth searching for. So we'll do that a bit later. We've got an app. I've got flag, set flag. This is just React hook creating a variable. Don't need to worry too much about this. Could be an extensive tutorial on React, but we're not going to have that. So we've got on click. When we click the button, the login button, we prevent the default so we don't submit a page or something like that. Then what we do is we create a value v, update it with the value here of the input box, and hash it and create a hex hash. Now what we do is we compare it to the hash above, and if it's the same, we can show the flag. Now, the way that the flag is shown is the flag isn't hard-coded here. The flag is actually derived using the hash as well. So what we do is we take this salty bit, concatenate it, and also hash salty and value together to give the flag. Then we set the flag value, and then that makes up HTM with that value there. So it means that we can't just skip the password check. The password check is important, it's vital. If we just skip the password check, the entire value of that is wrong. So you can't do that. But what we can do is so this hash, let's search it. Let me just make sure I've copied that. Yeah, okay, So it's a SHA-256 hash. So let's just kind of use Google, because Google is actually better at finding these weird obscure things. Search for it. And unsurprisingly, this does not show up anywhere. No one has hashed this exact combination of characters before. Great. So trying to brute force it is probably not a great approach. This is not salted, so if it was there, you know, we could go, if it was a known hash, we should be able to find it on Google using something like CrackStation, and you could go through those. It's a good place to start, but you know, that's not given us great results here. So take my word for it, it's not online. The password was deliberately designed so that wouldn't be possible. However, what we do is we hash it again here, and then we generate these values using these parts of this hash that we generate. So we take the first 8 bytes, and then we use that. You take the first 8 characters, interpret them in base 16, which is hex, and then we take and then multiply by the length of the icons. So we generate a number within this range that will reference one of these icons. So 3 icons. Then what we do is we also do take more bytes and generate them within the range of 65535. And what we actually do these all for is this becomes within 360. So actually, this is the max number that could be represented by 8 characters of hex. Then we divide by that to get a number between 0 and 1, and then we multiply by 360 to get an angle somewhere. Then these angles are used as colours, and the icons are used from this list. So this is the part that is generating the icons as we type. It is changed, so each of these is related. So looking at this code, we know that the SHA-256 hash of our password is represented by the SHA-256 of our password is generated to perform that exact combination. So if we type in T, no matter, T will always look the same. TA will always look the same. TE will always look the same. Right? So, what we can do at this point is, this is a kind of really kind of interesting thing, because we go, okay, it's all about the concept to understand here is a more crypto-y concept. So if you're not maybe familiar with it, I'll just explain it kind of in brief. What makes crypto and cryptography strong and hashes strong is the amount of entropy. A hash is secure. SHA-256 is a secure hash once you hash it. This password comparison is perfectly secure. It's bad practice because you're shipping the hash to the client and doing it all client-side. So it's bad practice, probably. But it's not actually insecure. And the reason it's not insecure is because this is a really long value. There are billions and billions and billions. There are billions and billions and billions of possible values for this hash. So when we hash values, it essentially randomly distributes it across that space. The entropy of it is very, very high. So we can't go and guess it unless we brute force all of the possible values to get this hash. So what an alternative option is we can look at these. These colours and stuff like that are all being generated to represent the current state of that. So how much entropy is there within just this thing? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 icons. We use 3 of those 12 icons, so it's 12 times 12 times 12 times by 65,535 to the power 3. So I'll just do the calculation quickly. So if I take 2, so I'll take 12 to the power 3 multiplied by 65535 power 3. That's this much entropy. Compared to SHA-256, that's a lot less. Right? So this is already kind of a slight insecurity. We've reduced the number of the entropy space of this down to this. There's going to be duplicates now within that, but it's not super useful. The key part is we get a color and set of icons for every single character we enter. every single character we enter, we get a new set. It recalculates it. So if we put in A, we get this. But if we put in B, we get that. So if we know the end result of, say, A, B, C, D, if we look at this, we don't exactly know exactly what combination it is. We'd have to try all the 4 character combinations until we got this exact combination. But if we know all of the in-between stages, on a keyboard, there's probably only about 40 characters maybe that you might be interested in using for a password. 40 is wrong, maybe about 60 characters that you're interested in using for a password. And probably quite predictable if the password follows words or something like that. So you could go, well, if we have a recording now, we can just try ones until we get the ones at the right step. So we can open the demo, skip past the horrible video and editing, and go to the very, very first entry. You can see the first character forms a blue compass, and this briefcase and that. So I'll just split the window quickly. Cool. So I want a character that will form that. So I can just try all of the characters until I get the right one. Almost, but it's very deceiving when you get things that look like they could be right, but they're not. Yep. I did not write an automated solution for this. Did people write automated solutions for this? I really hope you did. Yeah, I solved it this way. If you have an automated solution, please share your automated solution. It's P, great. Yes, please send your automated solution. I would love to see it. I'll look through it right now and show everyone what an automated solution would look like, because this is quite brutal. Yep, that's how I solved it. I manually tried every key and stopped and started the video. I think it does become a little bit easier. It does become slightly easier once you kind of start to get more characters, because you can start narrowing down your search. But yeah, so this is a lot less. Yep, so now we get an orange compass. So it's not A. But yeah. So you could watch me solve this for the next half an hour, I'm sure. But that would be exquisitely painful. So what I will do is I will just find my notes of what the password is. Go flag vault. Okay. If we put in pretty groovy to me, we get the right thing at the end of the video. Your solution was written in the dev console. So I assume what you did is you probably did, you extracted the colors and stuff from the video and used the symbols and kind of like notated it down, and then just kind of wrote the script to go through and try each combination until you got a match. Yeah, symbol list. Cool. Yeah, that's really cool. If anyone feels like writing an automated solution, knowing, oh yeah, the colours don't matter, you can just ignore the colours. You can just completely ignore them. That's really neat. I didn't quite realise that. Yeah, you just if you had more stuff available, you might get clashes with only the symbols. But I think because of the few characters that are used, you don't get clashes. Yeah, that's really neat. I like that. So if anyone actually if anyone generates an automated solution for it, please let me know. I'm keeping a wiki of write-ups for all of these challenges. So if you've got an automated solution, please let me know, and I'll put it on the wiki with your name and stuff like that, because that would be awesome. I didn't actually even think about doing an automated solution. Yes, the colours make it impossible. Yeah, thanks so much for that. I didn't realise that you would be able to do it an automated way. That's really, really cool. Maybe the harder version of this should be in a character that was like 256 characters long or something like that, with complete randomness, just to make everyone do an automated solution. How did I solve it again? I'll just go over it really quickly. The video shows that you can do shows each stage, each character, and the values at the end that are generated. So what we can do is we can try a character at a time. We can try a character at a time until we get a match. This is a match, so we know that that's the first character. The reason that's true is because we can look at the source code and work out exactly how these icons are generated. So slight diversion, but this is absolutely hilarious. So let's find it. Let me find the GitHub repository. Someone did this in the real world, and I'm going to find it. I haven't searched for it in a while. It's a closed issue, and it's a security vulnerability. Nope. How is a better way to search this? I think it was like... Yeah, Master Password did it as well. I think this was where it was originally... Yes, here we go. It's 2 issues. Here we go. Here's what they do. Someone posted this GIF in 2016. You put that all in, and it comes up with this nice little thing. And so someone included this demo on the website, and they were like, yeah, okay, we can work out what the password is, what the master password is that's being used to generate this. So it's really cool. It's a, you know, it's kind of neat. I really like it. It's like someone really screwed that up. Like how, but because it's a UI thing. It seems like a really neat idea. Like I've thought about this. What if like when you're entering credit card details, what if there was like a little symbol that showed at the end, and you could just glance at that, look at the one on your card, look at there, and you could see, that's the same. I've put it in correctly. But when you do it character by character like this, as long as you've got a video of it, you can reconstruct the entire password really, really trivially. So what's the solution? You can not do that entirely, or you can slow it down so that you don't show it until the whole password at the very end has been done, or kind of just make that final thing have more entropy than it currently does. But even then, that's difficult. So it's really interesting. I like this. I originally saw this issue with master password stuff, because I used to use some of these like stateless password managers, and so I became aware of the fact that they did this, and I thought it was really cool, and looked into it, and turns out it's not really that secure. And so I've been looking for a way to put it in a CTF challenge for ages. Thanks so much, Aaron. Yes, that's awesome. Totally recommend people read that. It's a really cool. I think it's a really interesting kind of security vulnerability, because it's not super serious, but it's a UI vulnerability. There's nothing wrong. It's not like there's a problem with code or something like that. It's the way that it's designed is fundamentally wrong, and the solutions for it are really, really difficult. Okay, so that's Flag Vault. Did I even put in the final password just to prove? Yeah, I did. I did in fact do that. Here we go. So the next one is mine, which I think a few people have been waiting for. This one. This is probably one of my favourite Capture the Flag challenges I have ever built. So hopefully you like it. So I've managed to find some useful information from the vault, so you managed to hack it. Get digging. We've got lots of precious minerals sitting around, but we only care about the gold. Try looking some of it up using our name server and using the map. Hopefully you'll get rich. Because we love our new users, we'll let you in on a little secret. There's already some gold stashed away. Okay, if there's a one-liner. Really? Really? Oh, that's cool. Okay, you got to share your one-liner. But I will show something that's not a one-liner. Okay, so I'm going to keep this open because this is one of the ones where the information that is given here is very important. Come on. There we go. The information... Let's just close that awful program. So this is like descriptions are important. When a description gives you a lot of information, you should read it. And especially when things are in quotes, that's a hint. Get digging. If you're not intimately familiar with some of the thing with like networking on Linux, it might be really easy to not quite realize what's going on. If you are, cool. The big hint though is using our name server. The whole problem is, what we can do is we can visit this URL, give some idea for the people who didn't get here. This is not something you can visit. This is like a, it's not speaking that protocol. It's not speaking HTTP. And so the whole thing is, this is one of the ones that it's giving a different protocol, and you need to work out what protocol it's using. So you could guess randomly. There's some port scanning techniques you could use. I tried for the write-up to do that. Turns out you can't. It just gets very confused. So we've got lots of precious minerals using the name server. The protocol that uses name servers is DNS. It looks up domain names. So you would look up something that looks like a domain name, something like that, and it would give you back an IP address. Dig is a networking tool on Linux used for doing DNS lookups. So yeah, this was a little more decrypting of the clue, and it was quite difficult actually to work out that that port was using the DNS. So what we can do is let's just construct like a simple test to make sure that this is working. So what I'll do is, using the name server at that, what we'll do is we give it the address, ctfcharles@midlands.com. We give it the port separately. We'll do short, otherwise we'll just get loads of stuff. I'll just show without first. And then we should give it what we want to look up. So let's look up x.y.y. And they say this is a coordinate, so let's put in 0.0. We get this. This is the answer section. We can see it more clearly with short, which is why I was going to use it. But you do get a lot of information like this. There we go. We get an IP address, an A record. It's an IP address. Cool. Neat. So it is speaking DNS. We're correct there. So we can move on. Let's try changing these numbers, looking at different coordinates. Let's try 1.2. We're getting some similar ones, some different ones. We can give it like something that we think will clearly be out of bounds, and we get no responses back. Okay. From this, we can kind of infer that there's some sort of map set out by and defined by this coordinates up to some limit, and at each of these there's IPs. Now, this is one of the I would personally think is one of the cleverest things I've ever thought of. IP addresses are a single byte for 4 bytes, and each part is each bit with a dot is a byte. If you are at all familiar with doing reverse engineering or CTF challenges, this will immediately stand out because it's in the readable ASCII range. These are ASCII characters. These could be interpreted as ASCII characters. So what I'll do is I'll just pull up Python again. Python is invaluable for CTFs. And I've already got a snippet somewhere here. There we go. And I'll just copy and paste this IP and split it up, interpreting each of these as an ASCII character, which is gold. And it did tell us that at 0, 0, there's some gold. Aha! So let's try some of the other ones some of the other responses we got back. This gives us silv, which we could assume is silver. This is iron, which is iron. Cool. That's kind of neat. So we can look up different metals at different IP addresses, and we want to find all the gold. Now, this is tricky because we don't know the ranges. We could find them kind of manually, but it could be really large. And if it's really large, then if it's stupidly large, that could just take a ridiculous amount of time. We don't really want to do that. So this is the only challenge in this CTF which is you really want to be writing a script that you really don't want to solve manually. Did anyone who did solve this, did they solve it manually? If so, I apologise massively. That's just not fun. So what we'll do is we'll write a script for it. Yeah, that's nice. So you could just print out each part of it like that. So what I'm going to do is I'll just write a very quick Python script to solve this. So solve or DNS solver.py. Cool. I've already got the script written, so I'm not going to kind of spend too long going over exactly how to do it, but I'll kind of just move along. Will a VOD of this be saved? I'm fairly sure so. Hopefully it shouldn't be too difficult to do. If not, and it doesn't get uploaded for whatever reason, then there will be text write-ups of all of these. Maybe not with all the detail of my lovely voice, but there will be write-ups that I've put an enormous amount of time into making. And the source code for all of these will be released as well. So you can host them yourselves, even when the Hack the Midlands server goes offline. So there's a library called DNS Python, which I have installed. So let's just import a few things for that. Cool. First off, the way that this works is we need to look up the IP of the DNS server. So let's just quickly get dns.resolver. And let's resolve the CTF Charles.hackthemidlands.com. And this will give us, if we print the result, cool, let's just run this. Gives us an answer object. This answer object can look like this. We just take the first answer that we get, and then we need to actually convert it to text because it doesn't do that manually. So that's not actually a string. Now it's a string. That took ages to write up. Okay, then let's store this result instead of printing it out. And this is just, we'll call this the HTM. So now we can do actual lookups. So let's do the part for lookup. So we have to manually construct a query this time. We can't just resolve it because we need to specify a specific port. And we want to search 0.0.9. We want to look up the A records. So we can get the result, 0.2text again. And then let's just print the result again. There we go. Print it again. Cool. We've gotten this bit. And this is the thing that we've actually looked up from... Have I screwed that up? Yeah, I have. It's meant to be message, isn't it? Oh, have I even made the query? No, I haven't even made the query. Here we go. We're going to make a query. We're going to use UDP. We could use TCP as well. This is one of the challenges that actually it listens on 2 ports. It says 4003, listens on 4003 UDP and 4003 TCP. Mostly because I did not want to cause utter pain and suffering for people who didn't realize you could run DNS over TCP, so that it would just work with all the tools that you were using. Okay, let's try that again. Query message object not subscriptable. What have I done? Message equals that. Let's print the result just like that. Okay, yeah, so we get the response from here, which is the metal. And then we can, to clarify, I have written, this is already written. Writing this involved vast amounts of consulting the documentation for this library. It's a neat library. It's not particularly obvious how to use it. So we can get the result.answer, print 0.0.2text, which will get the actual IP that we are looking up. And then we can print the IP. There we go. So this is the IP that we're actually looking up. Okay, so now that we've done that, let's make this in a loop. For I in range, or let's just put in a loop forever, shall we? While true. And we're going to put it in 2 loops because we want to iterate over all the x and all the y. So we'll make a variable, x is 0, y is 0. And instead of looking up 0, 0, what we'll do is we'll use a Python f string, which is wonderful, and use x and y as the coordinates instead of that. And at the end of our loop here, we will increment x, and then at the end of the loop here, we'll increment y. Cool. And what we'll do is we'll print the IP, but we don't want to print the IP. What we'll do is, if the IP is equal to what we know gold is, which is just this, then we'll print... My keyboard's getting a little finicky, sorry. We'll print X and not print a new line, but that means if we're not going to print a new line, we need to print a new line here at the end of the row, and otherwise we'll just print a space. Same end is equal to that. Cool. For X in itertools.count. Yeah, that's probably an idea. No easiness. Okay, so let's run this. There's a reason that's not worked. Passing the flush equals true option. If you don't, by default, Python will flush when it hits an end of line. Otherwise, it won't flush, and so you don't actually see any output, despite the fact it's printing. So we just flush. Now print out a whole line. Then we get an error. This is because we've hit the boundaries now. We have queried all the way correctly up to the end, and we've hit the boundary. So what we can do is, this is on line 15, right here. So what we can do is we can actually, instead of doing this neatly, actually checking, what we'll do is we'll do a try except this index error. And if we get that, that means we're done with a line. So we'll break from this internal loop, we'll break from this loop and come out to here, print the new line, increment y, reset x to 0, and repeat again. So let's do that. We'll wait for a moment. It will start doing something. You can see it's starting to form some lines. That's the top of a TM there. By the way, so I'm kind of doing this now. I'm going to publish some official write-ups. But if you've got completely different methods of solving them, please, if you want to write up your own write-ups on your personal blogs or something like that, then please do that. Tweet at me. I have Twitter. I'm at JEDEVC. Please tweet at me or at Hack the Midlands. I will share it, link it on the repository. I think it's really cool to have all of this stuff out there, and seeing how other people have done it and their styles of doing it is really useful, I think. And so we're doing this at the end, and now we're just echoing new lines forever. This is because we're continuing to hit errors. We can cause it to terminate nicely, and there's some logic we can do for that, but you know. We've got flag. So we've got HTM, an open bracket, and it says no, where, show. All caps. So we can go and submit that. Sure. That's the answer. Awesome. So this is the basic script for it. I'll release a slightly more nice one that terminates nicely and stuff like that. And it'll be in the write-ups. Yeah. So people have any questions about that one? Because I think that's one of the more difficult to kind of wrap your head around. So please, if you've got questions, let me know. I will be happy to answer them. Yeah, again, no idea how long the latency is, so I could just be waiting a bit. But yeah, all right, since I haven't seen any so far, I will assume that people have understood what I've done. I'm really happy with this challenge. I think it's a kind of a clever one because of how the gold works and the translations between all of that. So, the final challenge, or what was meant to be the final challenge, ship it. Yeah, I'm annoyed with how this went, but yeah. You can download shipit.tar. Thanks, Bede, for pointing this one out to me. I just was not thinking when I did this. It was quite embarrassing, actually. But Windows subsystem for Linux would have been a shout for that. Ship it dot to dot. Right. I think you can just do this. Yep, you can. Good. So this was meant to be a whole cool challenge about having a Docker image which you'd be able to unzip and import the image. But it's a tar file and you run strings on it to list all the strings in it. And you just get the flag. The flag was never meant to be in there. It was meant to be quite a difficult challenge, but the flag was just there. So, yeah. It should have. If we did it again, I'd make sure that the flag was not in there as easy, or that this kind of challenge would be much towards the beginning. There's some more detail in the write-up as to how this kind of is meant to work and what the intended solution is. But yeah, yeah, too bad. Anyway, the actual challenge that I was meant to have was uploaded to the next one. I'm not going to go into too much detail of this one because I think it's quite trivial. You can untar it and have a look round. But I really think you run strings to detect what ASCII strings exist in there, and it just spits it right back out at you if you grep for HTM, the flag prefix. So, yeah. Not even going to bother submitting it. Bonus auth is much better. Let's download that. No. SH is an ELF64 executable. So this is an actual program that you need to run. My camera has unfocused. Good. Thank you, OBS. Thank you so much for that. Do you know what the grand solution to this is? Right. Between them. Aha. Right, fine. We're going to solve it live then. Good. Yeah, off and on. I'm looking for the button to easily do that. Aha. Yeah, it does work with Discord. I'm not sure how to turn it off and on with OBS. Hello. Maybe it will refocus if I do some magic. Hello. Really? Really? Plug and unplug. I mean, that is a much better solution than what I was considering. Here we go. Give me a moment. Oh, good. Now my camera is completely frozen. Good. Let's try that again. There we go. Right. I can also set the properties in here to just not do that. No, focus is still, autofocus is turned off. Just, yeah, please continue to ignore my personal preferences about whether it should be done like that. Good, good, good. Aren't I I'm very happy with that. Okay, back to SH. It's an ELF binary. Oh, the editor I'm using is VS Code. Oh, really recommend it, especially with Vim plugins. Really, really recommend it with Vim plugins. Vim is fantastic. It's also really difficult to use Vim, actually, believe it or not, by itself, especially when editing huge amounts of like complicated Java and stuff like that is really not enjoyable to write in Vim. There are great plugins for Vim you can use. I've always had better results using VS Code, which has great built-in support for that, and adding in Vim stuff, and then pulling out real Vim for like editing 1,000-line log files and stuff like that. That's kind of the general approach I take. But yeah, I'm aware that I'm a fake Vim fan because of that, and that some people will dislike it. But you know, that is the way that I work. So it's a binary. It's an ELF binary, which means we can run it on Linux. need to give permissions to actually execute it, we can execute it. Enhanced protection enabled, triple password authentication required. Look, I'm putting a password. We don't get anything. This is unsurprising. It's probably been put together. So what we can do is we can try a couple of approaches. First, let's just be absolutely sure and let's just look for the flag by strings. There's a flag. It looks like it's been redacted. We could submit this, but this is completely wrong. It doesn't look anything like any of the other flags, and it's essentially all information is all gone, and so we're going to need to find a way to reconstruct it. So let's kind of have a look through. We can do more strings of SH. Have a look through. There's lots and lots of information about how it's compiled and stuff like that. There's also this other stuff about ABC secret key, Hunter root 4, stuff like that, but we don't know how any of this stuff is used. So I always prefer when you start to debug a program like this, I always try dynamic analysis first. Something like ltrace and strace are easy to use, they're very, very simple, and they can often reveal really good information for really basic CTF challenges. So what we can do is we can give that a try. ltrace relinks the essentially provides this barrier between the binary and when it makes a call to libc or any other library, and instead of actually executing it, it executes it and then also prints it out to the so you can see what calls it's making. So you'll say sh. So you can see I've made this function call setBuff. I've made a call, another 3 calls of that. I've put some data out to print it out. I've asked for the password. These are all standard things. You can see what's happening. It looks horrible, but I can see what's being done. So I can put in test, and it's loaded test, taken the string length of it and done it twice, and then compared it to Hunter root 4, and then immediately exited. Cool. This is a really neat way to see basic string comparisons going on. So what we can do is we can go Hunter root 4. All right, so let's just run that with Hunter root 4. Unlocked. Great. Now it's asking us for another password. So let's put in another password. And this time we don't get that string comparison. It's obviously checking the password in some different way. It's still doing that string length and it's still doing the puts, but it's obviously checking it in a very different way. At this point we could pull up something like GDB or something like that, but also what would be really neat is it's full-on disassembly is kind of where we end up going. So my personal tool of choice for this is Ghidra at the moment. I'm also a big fan of Radare, but Ghidra is so much easier to show people what's going on. So I'm going to open up a project in Ghidra, and I'm going to import this SH that I've got, and we're going to just analyze it with all the default stuff. Get a program. So for people who have not used Ghidra before, the NSA hacking tool. The NSA does make it. It's really cool. It's a great tool. I really, really love it. So we can see the program tree. So these are all the sections of the binary. In general, the .text section is where the program code is, and where the functions will be listed. BSS and data will both store some global variables. The PLT is also an important section that is brought up a lot. Lots of the other stuff, usually not important. They're used for linking and lots of libc magic. So we don't need to worry too much about that. The symbol tree shows all the symbols in the file that we can list it from dynamic relocations. Data type manager, we can ignore that. This is the assembly listings of everything, so the actual code. And here's one of the greatest things about Ghidra, and where it smashes every other tool out of the water completely. It has a decompiler which will try and give C-like code for what the assembly is. It's got really varying results. Some compilers produce code that it works really well with, but if someone's trying to make it really difficult to analyze, this will be nightmarishly unreadable. You will need to use something. Just read this manually. And if you're reading it manually, something like IDA actually pulls up better views of this, but Ghidra's decompiler is wonderful. So what we're looking for is we're just going to go quickly to the main function. You can see this lovely main function here. All the variable names have been guessed and stuff like that, but we can kind of start to see some of the basic structure. So at the very beginning, we make these calls to setBuff. We don't need to worry about what those do. For people who are interested, setBuff essentially sits there and makes sure that standard in, standard out, and standard error are unbuffered streams. They're raw streams that always that don't have an internal buffer. So it means that after every call to printf or puts or something, we don't need to flush. This isn't as useful for this, but for lots of challenges, it's really important that people do those flushes, or you can get some horrifically difficult challenges when you're trying to solve them on the server. So we put this out. We have this place on the stack, this kind of array of pointers, and in each of these pointers we store functions, check passwords 1, 2, and 3. And then 3 times we go through this loop. There's this character p. P starts off at the variable. P starts off at the beginning of this array and continues until it gets to. Where is the output? Yep, it will jump to this bit at the end of the function, which isn't shown in this compiler view, but it jumps to the end of the function right here. And so we can see what happens is that we go through, if we get to this point where shell access is rejected or given or whatever like that, we hop out back to the end of it and we're done. To the very end of the function, like out here. So that's pretty much what's happening. We're going through each function, calling them and passing the password to that function. So let's check out the password functions. Check password 1. We could read the disassembly, but the decompiled view for this is so simple. Cool. We take a target and a length. We compare the target and the target to this. If it's 1, we fill up the flag this global flag variable that we saw before with all the dots and stuff in it. We start to fill it up with some of the data from the password. So in this case, we make the 9th character of the flag, or the 10th because the index is from 0, with the last character here, so 4. So flag 9 takes the value of 4. This is an interesting approach, and something that should immediately indicate that we can't just skip the password checks. If we skip the password checks, flag never gets populated, so flag prints out to be that initial value. So the password checks are actually really important. We have to do them. They're designed to not be skipped, kind of like the hashing one a bit earlier. Okay, cool. So let's check out the other passwords. So here we go. Let's check password 2. So we start off with target and length again, another loop, and this time I is 0, so I is our counter as we're iterating through the loop. Gidra C is really good, but it often doesn't pick up on things like generating for loops and generates really minimal and really obfuscated C. But it's more readable than reading the assembly a lot of the time. How did it get the string flag? Binary Ninja showed it as a memory location. Flag is, so because of the way that the linking is done, the binary isn't stripped, so all the variable names are still in there. So Binary Ninja not being able to find it seems like a Binary Ninja kind of problem. I'm not going to lie. A good decompiler should be able to find those kind of things. So here we go. We've got that same kind of population if we hit this target and then we return from here. Okay, but let's look at this bit back down here because this is where the actual logic is done. If target I, so if for each character we do this, if it's less than 1 or greater than 9, the ASCII characters 1 and 9, then we break. This makes more sense, I think, if I pull up an ASCII table. So I can just pop down to here, and this is the section we're interested on right here. So from here to here. 0 goes here, and everything less than that is not a number, and everything greater than 9 is not a number. So essentially what we're doing in this step is we're going, anything less than 1 is we reject, and everything greater than 9 we reject. So we do that and break, and we say return 0. This password is completely incorrect. If, on the other hand, it isn't, if it is between those numbers, what we do is we take that number and subtract OX30. This might seem a bit weird. OX30 is in hex, it is the character for 0. So what we're doing is, say we input a 2, and we subtract the ASCII character for 0, so we subtract 32, we subtract 30 from 32, that gives us 2. So subtracting 0 is actually a really good way to convert it into convert it from a digit into a number. So that's essentially what that bit's doing. We just take that and convert the number that the character that we're given into the number that we can actually read. We take that number and we add it to the count times 10. So count starts as 0. So the first time we go through, if we input a 2, it will be 2. Then we put in another character. Say we put in 3. Then that becomes 3 plus 2 times 10 is 20 plus 3. So we get 23. So essentially each time we put in a new character, we go through and we shift it over and we keep adding digits to the end. Display as X, where X can be a character. Yes, we can do that. So we can do that here. Somewhere. I'm not great at Ghidra, I'll be honest. I have to spend a lot of time looking through stuff. Can I not set the... I don't think I'm missing it, I just can't find it. I don't think it's there. Oh well, the decompiler is just being silly then. Yeah, that's going to bother me now. Yeah, you can do to convert. Here we go. Yeah, chances was that. Here we go. So it's just done -0, which makes it more clear what's going on. Ghidra doesn't necessarily know what those things are out of the box, so it's just work those out. So you can kind of come in. You can rename variables as well in Ghidra. So if count doesn't feel like a great variable, we can call it count hello, and it will rename it all over there, which is quite nice. And if we save our project, we can come back to where we've gone and go see all the renamed stuff and everything. So count will be that. We increment and we keep going through. If count hello ever equals this value, then we're done. So let's convert it again, because that feels like a good thing to do. So convert, and we'll convert this to a decimal number, because that's what we're inputting it as. So if count hello is ever equal to this, then that's good. All right, so if we open sh back up, where's the actual terminal that I have solving this? There we go. So if I do sh, we know the first one is Hunter root 4. Hopefully someone gets that joke. 575. Unlocked. We've got to the next stage. Awesome. So, for the final stage, let's have a look at check password 3. It's a bit longer than the other ones. So this is a really common pattern in CTFs. If you look, some of this disassembly probably looks absolutely nightmarish, and some of the code looks really difficult to work out what it's doing. If you do enough CTF challenges, you will start to become accustomed to it. These things start to become really, quite obvious after time. Yeah, it takes a while to kind of fully absorb it, but it's a skill that you practice and do over time. So would highly recommend. If it looks really complicated, it kind of is, but it's a skill that you can pick up really easily just by doing it. Hunter 2, yeah, that's the joke. Cool, so what we do is we require the length to be something. So if length is equal to OXB, which let's just use my newfound skills in Ghidra to convert this. Let's convert this. So it's got to be of length 11. We set I, so we set another counter, and we go through here. Yeah, thanks for the. That's where the joke is originally from, by the way. So what we've got is in here we take the string length of the secret key of ABC secret key. Then we take I mod the length of the secret key. So this will kind of means that bvar will equal to bvar1 is equal to a character. So I'm going to rename this. I'll call this key character, key ch. Key char. Cool. So this is a key character. So it's taking a character from our secret key here, using I to index into it, and then it mods it by svar2, which is the length of the secret key, so key length. So it means that once it goes past the I gets longer than that, it will wrap back around to the beginning, which is a really useful trick. You can use mods to do that. Then what we do is we say if this goal variable, which we'll look at in a moment, if that character within keylen is not equal to the target that we've given mod the keychar return 0, which means we've failed. So we want it to not fail, so we want this to be equal. So goal 3, so essentially let's look at this side first, because target I is essentially the input that we're given, so we control that. Keychar is a character by here. Each character, each time we go through and step through. And we compare it to goal 3, which we'll look at right now. So goal 3 is this. This is an incredibly unhelpful view from Ghidra, unfortunately. So I'm going to just change these to look at, I can choose the data type, and I really want this to be, instead of trying to display it as characters, I want them to be bytes. Display them as bytes, that's much more easy for me to read. So these are just random bytes, 29B, 2E, 6H, blah, 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 blah. 35, yeah. So what we do is we can take all of those, and if so, for the first character, what we do is we go, is what our input XORed with A, is that equal to 29? Yes, continue. And so, we do that for each one. Is B XORed with what we give it, is that equal to B? If so, and so you keep going until we've done the whole thing. 11. Yeah, bytes are easier to read than characters because these are not ASCII characters. Some of them are, some of them aren't, so it just becomes very difficult to look at. So, that's kind of neat, that's kind of cool. How do we actually solve this? XOR is invertible. It's very easy to invert an XOR. So I'll just open up Python because, it's my tool of choice. So let's give something like AA, because that's recognizable. And we'll XOR it with XO, OXBB, or something. We get this value, OX11, which is 17 in decimal. But if we take OX11 and put it with OXAA, we get OXBB. No, we don't, because I can't type. Get OXBB. And if we do the same thing with OXBB and OX11, we get OXAA. So it's invertible. You can invert it in every way. So essentially, what that means for us is this can move to the other side of the equation, kind of. So the keychar can be moved over to here because we know what all the things of goal 3 are. We know what keychar is going to be at every stage. So all we need to do is so we can use that fact to work out what target I should be. And then once we work out what all of target is, we can populate the whole flag and, then we'll print it out nicely at the end. So to do that, what we can do is I'm going to write a quick little Python snippet because this is actually quite fun to do. What we're going to do is we can do it all within the Python interpreter in one line. So we're going to use an array comprehension to go through character by character. So first off, let's just give 0 because no, it's not what we know. So we say 0, 4, and then let's go for the key character and yes, in one line. We're going to do it in one line. So we can do the key character for that, and then we also know the goal character. So let's get that, get K, G, in, and what we're going to do is we're going to use a zipped iterator, so we can give it 2 sequences and it will spit them all out properly. And so the key is, we know ABC secret key. Or actually, here's an idea. Let's put these in byte strings, which will be better for Python because it will make me less want to die. Okay, then we need the byte string for this goal. So let's go grab that, and I'm going to manually transcribe it into Python format. Hopefully this is all right. I'm leaving off the H's at the end. That's just an indication. That's Ghidra's way of saying this is hex, because often it can be very difficult to tell what each thing is. What the hell? This is what I get for using Vim key bindings in my Python interpreter. 4, and then we're done. 21. Cool. So I do that, and that will zip it all up correctly. Then all I should need to do is XOR K and G. I'm using... Wow.
That is unhelpful. I think we could rename this stream to Justin Struggling for however long. Now we get this. This looks a lot better because all of these look like they're in the printable ASCII range now, as opposed to what we were getting before. These all look like they are printable. So what we can do is we can take that and just use the byte array function and convert it. We can get this. So you get Hi Muppet God as the key, and we'll just paste that directly into SH. And this gives us the flag. The game is up. And so all of those passwords are used to construct the final flag, and so all of the parts are required. And so yeah, this technique of kind of XORing stuff together is really, really noticeable in lots of CTFs. You can tend to pick up on the pattern of there's a loop and it's looking through this eye and it's being used to index into strings, and then it's XORing and you go, oh cool, I don't even need to read the entire thing. You can just XOR them together and guess. The reason that this is kind of a little bit confusing is because definitely while the easier challenges were easier to step through, the harder ones were starting to get into something that was more challenging. Intentionally, you know, I think it's a bit boring if everything stays at the same level. I think my philosophy for designing the Hack the Middle and Capture the Flags has kind of been, you know, everyone should be able to make progress and everyone should be able to get to at least halfway. Even if they don't have prior experience, they should be able to research and learn the stuff. But I do think that some of the stuff towards the end should definitely be designed to be harder, so that, you know, it makes it more satisfying and it gives people something to aim for and a skill to get. Where does this rank on the difficulty scale of 0 to 10 for me? I would probably rank this at about... this last one, probably at about a 5. Sorry. Yeah, I know you want me to say it's higher, but I think maybe a 4 or a 5, because the first two passwords are... First password's very easy. The second password you can just glance and you can find this number. And the third password is an XOR, which you can use a Python snippet for. In terms of reverse engineering challenges, there's not that much extra code hidden around. Some reverse engineering challenges will purposefully hide everything. It's not even clear where the key is, where the flag would even be. That being said, binary analysis and pwn challenges and reversing engineering challenges, those are what I do. I'm in the hacking club at university. That is my area of specialty. I do that for fun. I do quite a few CTFs and stuff like that, and that is the area and the stuff that I personally choose to do. So I've put a lot of time into it, and seen some really horrible ones. If you're interested in seeing what's out there and practicing a bit more, you can. This type of challenge is what's called a crack me. So let's find out. So these are like some crack me's, and so they're all those kind of challenges where you look into them and there's inputs that you have to give them to gain insight into what's going on. But yeah, I find them quite fun. I really like them. That's kind of all the challenges. Is there anything that people want me to go into in more depth, or kind of talk a bit more about any of the challenges specifically, or is it time for me to launch into here's how I Dockerized everything, if people are still interested in that? Yeah. Before I go into backend, is there anything that people want to cover related to the challenges still? I'd like to talk about the backend stuff because, I think the infrastructure side of Capture the Flags is really interesting and no one really talks about. I'm not sure whether that's because they're ashamed of it or because they're not infrastructure people. Flag Vault, I've got a better description of what actually is going on in the write-up. So what I will do is once this is all done, I'll give you a link, and you can all visit it and see the write-up. I think that's better than how I explained it. I'm not sure how I can explain them better, unfortunately. I think my writing's probably a lot clearer, and I'm not going to read from it because you can just look at it later. So sorry about Flag Vault. I will definitely... I think my description's clearer. I'll go through some of the thought process as well as I'm going through the back-end stuff as well. Okay, So let me just sort up my window over here so it's slightly less toxic to look at. So I've got another monitor where I've got all the Twitch stuff, and I'm trying to manage it reasonably. So we can close Gidra, who cares? All right, so for the back end, we have used, I'll pull up the repository now of the actual code that all got used. So this is the whole repository of everything that's going on. There is a lot going on. I've specifically kind of designed tools over time that are good at doing these things. Yes, I can turn the music down a little. Thanks for mentioning it. 100%. Yep, there we go. Let me know if that's still too loud. I'll turn it down even more. So the whole point is deploy and capture the flags is I like to automate everything. The more automated stuff is, the less I'm likely to go and screw it up a little bit. So the whole way that this is organized is a few years ago, I wrote a script called CTF tool. And it's a kind of long script, 565 lines of Python. And it's quite a neat script, I quite like it. So just run it. Essentially, this manages all of my challenges and lists the data for the challenges. It doesn't handle any of the deployment stuff for it, but it handles kind of all what you see on CTFD, the score platform. All of that data is defined within these lovely, let's look at the Discord one, challenge.yaml files. So they define the flags, the number of points it's worth, some basic metadata about how to deploy it, as well as like data about how to upload it. So it's kind of like all of this stuff is here. And I can list them. There's also some validation scripts in there to make sure that I've not actually screwed up writing them. So like I don't have duplicate challenge names, that I've actually given flags, yeah, get remote access to my laptop. Yeah, so it's kind of like, this is where all the flags are stored. They're all kept in these challenge.yaml files. It's quite nice. I've spent a lot of time kind of refining this format and fixing up that script. It's entirely separate from everything else. I've also kind of look after this infra repository, which is kind of like CTF tool is just for managing kind of the state of stuff on CTFD. But the actual deployment is slightly different. So I've got this deploy folder here, and I've got setups for Docker Compose and Kubernetes. Kubernetes means I can deploy it nicely, but Docker Compose is so much easier to develop with because especially you can do stuff like Minikube for developing Kubernetes locally, but especially when you've got lots of ports open, setting up the port mappings between VMs and local setups, it just gets really difficult and frustrating to manage. So it just becomes much easier if I can test locally in Docker Compose and only deploy the final version on Kubernetes. So essentially what I've got is Kubernetes one is a lot more interesting. I've got some Kubernetes configs, generate.sh. Essentially what I do is all of these config files are configs. I use I've got environment variables get pushed into these, and also for the challenges.py, this script generates Kubernetes YAML files. So you can actually look at them. Let me find one that doesn't have credentials in it. Login.yaml. So this is the setup for login. So it defines all the Kubernetes resources that have been created, and kind of deployments and all the setups that we need to actually create all the different parts. It's really, like, the scale of it is quite small, but actually managing it with Kubernetes is really nice. I really, really, really like the fact that I can just say, yeah, I'd like to have two. Do I have credentials in there? No, I don't. I have credentials in some places. This is the build YAMLs. The YAMLs, because I have to generate the secrets, Charlie, to generate the secrets. Kubernetes being at this scale, I'm unsure. Like, it's quite nice. I like the ability to be able to say, actually run 2 copies of this challenge and load balance between them. That doesn't work for some challenges, like Discord running 2 bots would be not okay. But it's quite nice to be able to have a setup where I can have multiple containers and stuff like that running for each challenge. I also really like the management of secrets and the fact that I don't need to mess around with the server. It's kind of like it's like Docker, but it does it automatically. And also, the CPU load on the entire thing, I think having run it on Docker I'd have had to have a much larger instance. I just had 3 nodes, fairly lightweight nodes, but they've all been sitting about 60%, 70% CPU kind of throughout the competition. So it's kind of like, feels like Kubernetes is an okay use case, but I'd be really skeptical about applying it to other smaller projects. I just do like it with this. This has been my excuse to properly learn it. 3 months ago. How long has this been in the works? Time. Sometimes quite a while. The infrastructure for this, I've been working on this. The first time this really started to see the light of day is for a CTF that we ran I ran with the Hacking Club over the summer at some point. So that part of that was I built that for this. So lots of the infra is, I think, when was the mine? Mine was built. When was mine built? Like 3 months ago. Yeah, I built mine ages ago. I think that was one of the first challenges I built for this because I really liked the idea. Tux was written quite a while ago as well. 3 months. Yeah, I started doing it. I specifically set it up so I would start it all and finish building everything before the start of term, because I'm taking 80 credits this term, which is horrific and a terrible idea for everyone who's thinking of doing it. Why can't you get a response using HTTP, not even a 404 for mine? It's a good question. HTTP is a protocol spoken over TCP, and essentially when you look at an HTTP request, what it's kind of doing, if I just open up... if you just open up if I just open up a connection to things, what it's doing is it's making requests that look like this. Like, you know, I can't remember exactly, like, looking up things. It's like making a request that looks like that and the server sends back a response. DNS is traditionally spoken over UDP, which is an entirely separate underlying layer, and doesn't send anything remotely like that. A server does not even understand. If you send it that, it just doesn't even understand what that is. In this case, we're running DNS over TCP and UDP to avoid confusion. But even if you send that data, this TCP server still has absolutely no understanding of what is going on. It just doesn't understand. It's waiting for you to make your DNS request, and you don't. So it just kind of hangs. That's why you can't get a response. 80 credits and I made this. This is why I got all of it. This is why it's been done 3 months ago. Because I started working on it during my internship, because I knew that 80 credits would be horrible, and it is horrible. So what we do is we don't do any of it during the term. So pretty much all I've had to do for this is do a final deployment of the Kubernetes cluster. That's pretty much all I've had to do, and make a few changes to kind of handle that. Yeah, just built it during full-time work. Very easy. The mine one is really interesting. The script for it is really short. I really like it. It's one file. It's one Python file. So it defines, like, you know, as you do, 15 lines of big string, and then it's a 75-line script. It's a twisted. Twisted is like an async await tool for building servers in Python. I don't really like it. I'm not a huge fan. I think it's being slowly replaced by the fact that Python has native async await. So when you want to do async await, you usually want native. Twisted does it and has really weird interoperability between it. But, like, you know, one thing that it does have, and this is why I came up with it during my internship, is like week 1 of our internship, they're like, we use Twisted, do a tutorial. I like do some tutorials, read into it. And I'm like looking into it and going, Twisted has a way to define programmatic DNS servers. That's awesome. So we have a programmatic DNS server defined here. It's really, really simple. Essentially, on every single query, if we look up and say, does this query does it actually look like .mine? If so, we can reply to it. Otherwise, we fail. And if we can reply with a mine, if it ends in .mine, we parse it, extract all the right data, look it up in the map, get the type of gold, silver, whatever it is, and then finally we join it together to create an IP and just return that as a response. It's a really simple, neat script. It took me ages to work out how to do it in Twisted, but I really liked it. It was quite, it was really quite nice to build this, and like, because it's quite a simple challenge. The idea took forever. I was thinking, I really wanted to have a maze where you used DNS lookups to navigate a maze, and where each part would kind of get you to go to the next part of the maze, where you would say something like, you'd look something up and it would say up, down, left, right, or something, and you'd go to the next bit. But the problem is at the end of the day, how you're going to be doing that is really annoying, because all you're going to be doing to solve that is just scan the whole maze and you'll find the whole thing. So I'm like, well, if you're going to scan the whole thing, why not make the challenge just scan the whole thing? I 100% used Figlet for that. I don't have it installed here. I did this on my laptop and I'm on my PC at the moment. But yeah, I used Figlet for that and kind of cheated. Well, not cheated. I 100% did not want to write that manually. So that's that challenge. The Docker files are really nice and simple as well. There's some, are there instructions? Have I written about how to actually... Yeah, I've written some documentation about how you can actually run these challenges yourself and host them all locally, including the CTFT scoreboard, which, of course, that's all bundled together. It's part of my work in doing the infrastructure stuff is I want to separate it out so the scoreboard and everything is entirely separate, so I could run them on different clusters and stuff like that. So that would be something that I'd be really interested in doing. Yeah, that's kind of a lot of the challenges. None of the other challenges are particularly interesting in terms of implementation. I'll be uploading them. Oh, I can explain why this ship it was bad. Ship it and bonus auth, the code is pretty much identical. Or was identical. I screwed up and left this hard-coded flag, which I'd intended to comment out and remove. It was just left in there. So you could just strings the whole thing and get the flag out. I'm like, oh. Yeah. So that challenge became a lot easier. So I patched it to make this challenge a lot easier, to just do a simple password check, and then did this one to patch even with the actual more difficult challenge. But yeah, so I've just got a couple scripts I run and I update everything on the site, which is really, 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 really nice. So unless people have more questions about, oh, how could I forget? Here's my Kubernetes monitoring. I use Lens for it, so I can see all the nodes, the status of the nodes, what they've been up to, what they're doing. I can see the workloads that things are doing, the pods that are running, deployments that are happening and going on. So I can see that Flag Vault deployment is running 2 copies of itself, and I can see kind of the CPU and memory and network and stuff that they're doing. One of my favorite things that I can do is I can go to the Discord pod. I can go to the Discord pod and view the logs, and so I can see all the logs that people have sent. So I was the last person to request stuff from it, but you know, I can see all the logs that everyone submitted and see how long people took to solve them and how many attempts they did it in. It's quite cool. I really, really liked. It's something I'm usually quite bad at, is I need to get better at doing logging, because sometimes it's really useful to be able to see. So if someone's messaged me and said I need a hand with this, it's really handy to be able to look in and see, okay, what responses are they actually submitting? When they say it's broken, is it actually broken? Are they not going to be broken? You know, so that's really useful. None of the challenges broke during the event. One of the challenges, the login started getting really slow. So I did a fix for that, but I've had experience fixing it, that exact setup being slow before. Something to do with GUnicorn, which I haven't investigated, but the answer is to remove it and to run it through the Flask development server. Yeah, how long a challenge is going to be up for? Challenges are going to be up for. I haven't decided yet. How long do you want them to be up for? Is the answer. I'm probably going to keep them up for at least another week. Maybe a couple weeks. It's not hugely expensive to run. It's 3 nodes on a cheap hosting platform. Hetzner is wonderful. So it's not like it's going to cost me an absolute fortune to keep it running. But yeah, it's kind of, there's going to be instructions for how to run it yourself. So even when stuff goes down, you can still run it yourself with just a little bit more effort. But I'll leave it up for a little while. and kind of, but yeah, obviously I'm not going to be kind of babysitting the cluster as much. So if stuff goes wrong, I probably won't notice until people let me know. Yeah, I've also removed all the dependencies between all the challenges, so you can attempt any of them and skip which ones you want. So if you want to skip Flag Vault or something like that, go ahead. What else? There was another one I missed. Regarding mine, why can't I get no, I hadn't said that. How to get root from the fake shell. I'm not quite sure what you mean by that. I'm not sure what you mean. If you could clarify, I'll answer. Yes, Hetzner is what I use for Kubernetes. I actually was like, hey, you know what? I'm going to use Google Cloud Platform for this one. Google Cloud Platform is like an entirely managed setup. I'm really interested in doing that. I've used it before, or Charlie's used it before, and I've watched Charlie use it, and it's really nice, and I really like it. So I was like, okay, well, let's try using that. Kubernetes on Google Cloud Platform at the time of me saying this now doesn't support version 1.19, which is the latest version. 1.19 came out a few months ago, and I ported all of my infrastructure stuff to 1.19 because I'm like, 1.19 is new. They've made the ingress resource, which I make quite a lot of use of. They've made that general availability, changed some of the syntax. So I'm like, okay, I'll port all of it to this. It won't be that much work. It wasn't. And then Google Cloud Platform doesn't support it, which is like, great. I'd have to backport all of this or run an older version, and I'm just like, that sounds really annoying. So what I'm going to do is I've got a little script. And pull up the script. It's in the hcloud folder, which I have committed without credentials. So I've got all sorts of useful things there. But setup, I've got this function called cloud cube, and what this bash script does is it uses the hcloud command line tool and essentially spins up 3 servers, makes one of them the master, puts 2 workers, and spins them all up and joins them all into a cluster together. And because it's only for a short time, it doesn't need too much more than that because, it doesn't too much more than that because, that's it. In a better setup, it would have some sort of automated upgrade process. But like if I'm running it for a week, the chances of me needing to apply an urgent upgrade are quite low. And if I need to, then I want to be doing that manually anyway. I don't want to have to be forced to do that. I don't want automatic upgrades going on. So yeah, that's kind of how I do the Kubernetes. It's not a managed cluster. Managed clusters are nice, and I think they'd be really cool for like larger scale stuff, but hosting your own is actually quite a learning experience, and I find it quite fun to do, especially when it works out so cheaply on Hetzner. Okay, the fake shell. Yes. Okay. So here's the code for fake shell. Flagbot sits here, takes messages, runs them with fakeshell.run. In fakeshell.run, there is no sudo. Sudo is not defined. These commands, it's not a restricted shell, because a restricted shell kind of implies that what we're doing is it's actually running processes. It's a fake shell in that it never leaves the process. So it just never leaves the process. It's not running system commands. It's not actually execing anything. It's all done in process, faking and pretending to be a shell. So there's no way to do sudo because I haven't implemented sudo. That's it. Like when you say who am I, it just returns a static fixed value. When you do groups, it returns a fixed value. So there's no way, unfortunately, to do that. I mean, I say unfortunately, it was specifically designed so I wasn't giving people just root access to a box somewhere, or that they could like put in a fork bomb or something and just really screw up for other people. Yeah, it's how do you run CTF challenges? How do you run CTF challenges where they're secure and people can't screw it up for other people? It's a really difficult question and something I'm still looking into. I'm looking into one of the things I'm looking into is called Firecube. It uses Firecracker by Amazon, which spins up really lightweight VMs. It uses that for Firecracker and runs each container in its own individualized Firecracker instance. So it's Kubernetes on top of it's Kubernetes, but instead of spinning up Docker containers, they spin up Firecracker VMs. So it's obviously more heavyweight, but you can really isolate kind of so that container breakouts are no longer feasible. You're not going to be able to do it. You've got this much larger range of protection. Something like gvisor as well looks like an interesting tool. But yeah, it's really hard how to do those security for that. I did not use my magic file system thing. It's difficult to get. I haven't used that in ages. I have no idea if it still works. It probably does. But for implement, I'm actually working. I say this. I've been working on it for a year with like very little progress. But I really want to have a blog series about how to implement a shell from scratch. And the idea is it'll be 1,000 lines of code and kind of just explain all the fundamentals of 1,000 lines, no extra dependencies, do all the parsing and everything from scratch. Cover like all the main features you want, like file redirection, piping, all those really cool essential features that people might not necessarily know a lot about. And so I really want this blog series to exist. I've written all the code. It's really neat. I've divided up the code into chapters. I just need to write it. But 80 credits. So I just have no time for that at the moment, which is really sad. Any more questions? Because I'm kind of feeling hungry and I'm going to get lunch at some point, because at some point later this afternoon I'm popping back on the stream with Will Russell. Hopefully you guys have heard of him. And going to be popping back on the stream with him, and we are going to do some talks about we're going to be talking kind of about old hackathon projects that we've done. So if you submitted a hackathon project and are really unhappy with it, come along and watch. Put us on in the background of your favorite browser or whatever. We're just going to be running our old hackathon projects and kind of working out the absolutely terrible things that we wrote, code reviewing ourselves 2 years in the past. Bit rot is a thing. You don't really believe it until you have it, where code just stops working because things have changed. So yeah, if you want to kind of see some of the stuff that we've done and watch us fix all of that, please come along. We'll probably hop on that in about an hour or so. But yeah, so as long as there's no other questions, I think I'll sign off. Hopefully you've all enjoyed this. I'm actually really happy with the number of people that have come along and hopefully been doing that. Oh, one final thing before I forget. I'm going to open source this right here and right now and make it public. Here we go. Dun, dun, dun. Ta-da! I'll put the link in the chat as well. Go. Yeah, it's the danger zone, There are no... If you do find credentials in here, congratulations, please let me know. Let me just fix this. Yeah, it uses a sub-module for the wiki, which is quite fun, because the wiki is hosted here. So I've got a sub-module for the wiki, which I can commit to and work on it from there, which is kind of nice. But yes, please have a look at it. Potential security vulnerabilities. Oh, it's all flag vault. Who cares? It doesn't matter. So, if you like it, feel free to star it or have a look from that. And if any of you have any solutions for write-ups or things you want to share, please tweet at me on Twitter. I will be really happy to retweet, put them and link them on the GitHub for with a section with write-ups, because I think it's really important that we can have something like that. If you've done the work to do a write-up, yeah, it should be really good. All right, I'm going to sign off now, and hopefully see some of you again in an hour. Good luck. If you haven't slept, maybe go sleep though. So yeah, see you all another time. I will stop the stream once I can work out how to get OBS. Yeah, see ya.